Hello, in this video, I'll be solving questions on A2 Equilibria from May-June 2019, paper 4-2. Question 1. C. Consider the following two equilibria and associated data values at 298 Kelvin. The equation for equilibrium 1 is AgBr solid dissociates to give Ag plus aqueous plus Br minus aqueous. The KSP value is 5.0 times 10 power minus 13 mole squared decimeter minus 6. KSP is the same as solubility product. The equilibrium equation 2 is giving us Ag plus aqueous plus 2NH3 aqueous gives the complex Ag into brackets NH3 brackets close 2 plus aqueous. The K star value for this equation is 1.7 times 10 exponent 7 mole minus 2 decimeter 6. K star is the same as equilibrium constants. It is used in complex formation to measure the stability of the complex ion form. The equilibrium constant for equilibrium 1 is the solubility product KSP of AgBr solid. The equilibrium constant for equilibrium 2 is the stability constant K star for the formation of the complex. I. Calculate the solubility of AgBr at 298 Kelvin in mole per decimeter cube. Solubility means concentration. And the only thing we know about this salt is the solubility product. So it means we can use the KSP expression to find the solubility of the AgBr. The KSP expression for this salt is giving us the product of the concentrations of the ions of this salt raised to the stoichiometric amount. In this case, the stoichiometric amounts of these ions are 1 and 1. So any value exponent 1 is the same value. So we leave it as this. But we don't know the concentrations of these ions. However, we can deduce them from this equation. Now, you know when a salt is in solution, the salt will dissociate to give you ions, and the concentration of the salt is the same as the concentration of the ions. So if the concentration of this salt is X, it means since the mole ratio between this and the ions is 1:1, it means the concentration of the ions will also be X and X. And so since we know the KSP value as 5.0 times 10 power minus 13 mole squared decimeter minus 6, and this is equal to the concentration of the Ag plus is X and that of the Br minus is X, so that will be X times X and that will give us S squared. And so to find X, we find the square root of both sides, and when you do that, you get X to be 7.1 times 10 power minus 7 mole per decimeter cube, and this X is the same as the solubility of the AgBr, so this will be 7.1 times 10 power minus 7. II. Use Le Chantelier's principle as applied to equilibria 1 and 2 to suggest why AgBr solid dissolves in concentrated ammonia. To explain this, we can take the two equations over here, one after the other, and see what happens to them when concentrated ammonia is added. So in equilibrium 1, you have AgBr solid reacting with the 2 moles of ammonia, and this gives us the complex Ag into bracket NH3 2 plus Br minus, all of them aqueous. Now what this suggests is that as concentrated ammonia is added to the AgBr solid, you can see that the AgBr dissolves and the Ag plus from this salt is compressed by the ammonia, and so we can see that the equilibrium is shifting to the right side as the complex is being formed. This simply means that Ag plus concentration is decreasing at the left side as the equilibrium shifts to the right side to form the complex. So we have to say that in equilibrium 1, the Ag plus concentration decreases as the equilibrium shifts to the right side. But this is 2 marks, and so it means that we also have to talk about equilibrium 2, as we can see over here. In equilibrium 2, concentrated ammonia is added to Ag plus, and according to Le Chanteler's principle, when a change is made to a system in equilibrium, the equilibrium will shift so as to oppose the change. So in this case, as we are adding ammonia to the concentrated ammonia to the left side, it means that the equilibrium position is going to shift to the right side so as to oppose the change we are exerting at the left side of this equation. And as that happens, the AgBr is going to dissolve, and then the equilibrium is going to shift to the right. So it means in equilibrium 2, as the concentration of ammonia increases, the equilibrium shifts to the right, and this also helps dissolve the AgBr solid. I. Use equilibria 1 and 2 to construct an equation for the reaction of AgBr solid with concentrated ammonia. This is equilibrium 3. So over here, we are simply going to add these two equations together. So we add reactant to reactant and product to product. So we have AgBr solid plus Ag plus aqueous plus 2NH3 giving Ag plus aqueous plus Br minus aqueous plus the complex Ag into bracket NH3 2 plus aqueous. So over here we can see that Ag is at the left side of the equation and at the right side of the equation, so we can cancel the two out and we have just this left. AgBr solid plus 2NH3 aqueous giving Ag into bracket NH3 2 plus aqueous plus Br minus aqueous. IV. Write an expression for the equilibrium constants of equilibrium 3, KEQ3, in terms of KSP for equilibrium 1 and K star for equilibrium 2. So for this, the equilibrium constant 3 is basically the product of the KSP and the K star. So KSP times K star. Now, how do we get this? Equilibrium constant 3 was actually gotten from equilibrium equation 3. And so for the equilibrium equation 3, constant 3, that will be equal to the multiplication of the concentrations of the product divided by the concentrations of the reactants raised to the stoichiometric amount. But we don't include solids in equilibrium expressions. So it means K3 is equal to AgNH3 2 plus, so concentration of this complex times the concentration of the Br minus divided by the concentration of NH3, and so the stoichiometric amount of NH3 is 2, so this will be exponent 2. In actual fact, this K3 expression was actually gotten from the multiplication of the KSP expression and then the K star expression. The KSP expression is gotten from equilibrium 1, and which is given as KSP is equal to the product of the Ag plus concentration and the Br minus ion concentration. The K star expression is gotten from equilibrium equation 2, and so K star is given as concentration of Ag NH3 2 plus divided by concentration of Ag plus times concentration of NH3 squared. Now, if we multiply these two equations together, we get concentration of Ag plus ion times concentration of Br minus, which is from the KSP, times the concentration of the complex divided by concentration of Ag plus times concentration of NH3 squared, which is the K star. And so finally we get this, and since Ag plus concentration is here and is here, we can cancel the 2 out, which means finally we are getting that. And this is basically the multiplication of the KSP and then the K star. Thank you for watching. See you in the next tutorial.